Right now we're going to talk about resonance in pipes. There are, for instance, half-open pipes. In a half-open pipe, sound will be entering by the open and will generate a node in the other extreme. The first mode that can actually be generated is going to look like this. Then, in the second mode, we are going to have a node, but it will end up in an antinode. The wave will look something like this. In the third mode, we are going to have three nodes such that the wave is looking like this. You cannot visually see this like in the strings, but this is what happens in a half-open pipe. In the first situation, the length is going to be 1/4 of the wavelength. In the second situation, the length is going to be, for instance, 3/4 of the wavelength. In the third case, this is going to be 5/4 of the wavelength. This is not a very direct relationship as the one in the strings, but we can generate that L is going to be equal to 2n minus 1 over 4 times the wavelength, n being the mode. This is the first mode, this is the second mode, this is the third mode, and so on and so forth. Such that at the very end, since we know that velocity equals frequency times lambda, the end frequency is going to be equal to 2n minus 1, being n the mode, times the velocity of sound in air over 4 times the length. This happens in a half-open pipe. A very similar situation can be happening in an opened pipe. So we have two openings. In this situation, for instance, if we have the first mode, we will have, for instance, a node . In the second situation, we will have two nodes, for instance, and in the third situation, we will have three nodes, and so on and so forth. This is the first mode, the second mode, the third mode. In the first mode, the length of the pipe is going to be, for instance, 1/2 of the wavelength. In the second mode, the length is going to be the wavelength. In the third mode, we're going to have, for instance, 3/2 of the wavelength, and so on and so forth, such that the length is going to be equal the mode over 2 times the wavelength. If the velocity equals the frequency times the wavelength, then the n frequency in this case is going to be n, the mode, times the velocity of sound in air over 2 times the length. This happens in a in a completely open pipe. It is exactly the same situation in this case as the waves on the string.